In this lesson, we're going to solve 2 by 2 systems of equations symbolically using the substitution method. So let's remember, when we're solving a system of equations, we're looking for the value of the unknowns that make both equations true. So visually, we're looking for the intersection of the two equations. The steps we're going to need to take to solve by substitution is to first solve one of the equations for either x or y. It doesn't have to be both. Just pick one that's easier to solve. We're going to use that expression we found in step 1 to substitute it into the other equation. We're going to solve this new one variable equation, get a value for it, and then use that value to find the other unknown. We're going to check our solution in both equations. We could also check it graphically, which is what I'm going to show you how to do. And we'll write our new solution as an ordered pair. So we're going to solve this system by substitution. So looking at both of these equations, I noticed that the bottom equation is going to be easier for me to solve for one of the variables. It'll be easiest for me to solve for y. So all I need to do is subtract 2x from each side, and my new equation is y equals negative 2x plus 9. I can now substitute negative 2x plus 9 in for y in the top equation. So I have 3 times negative 2x plus 9 minus 2x is equal to 11. And now I have a linear equation that I can solve. So I'm going to distribute and combine my like terms. Once I isolate my variable, I have x is equal to a positive 2. I now need to go back and find the value for y. So I'm going to go back to this equation that I rewrote. Y is equal to negative 2 times 2 plus 9 so y is equal to 5. So my solution here is the ordered pair 2, 5. Okay, we can check this in two different ways. We could check it by substituting 2 in for x and 5 in for y into both equations, or we could check it by using the graphing calculator. We're going to do both ways for this first problem. So remember, my solution that I'm checking is 2, 5. So 3 times 5 minus 2 times 2 equals 11. 15 minus 4 equals 11, and that checks. Let's check it in the bottom equation. 5 plus 2 times 2 equals 9. 5 plus 4 equals 9, and again, that also checks. Okay, we always want to make sure we check in both equations because we don't know where we could have made a mistake. So we want to make sure both of those equations are true. To check our solution using the graphing calculator, we're going to have to make sure both of our equations are in the y equals mx plus b form. So my top equation, when I solve it for y, is going to be 11 thirds plus 2 thirds x. My bottom equation is going to be negative 2x plus 9, just like we solved earlier. Okay, I expect my solution to be at 2, 5. So again, I'm just going to use that standard window. Okay, both of my equations have been plotted. Just by glancing, it looks like our solution is about where it should be, but I'm going to double check by using that intersects feature under the calculate menu. Okay, and I do see my intersection is at 2, 5, so my answer is correct. In these next two examples, again, I'm going to show you how to do the substitution method, but I'm going to skip showing the check. I'm going to let you do that on your own. So if I look at this system, x plus 3y equals 3 and 2x plus 6y equals 6, I notice that the top equation would be a little bit easier to solve for the x. So when I solve for x, I get x is equal to 3 minus 3y. So again, I can substitute 3 minus 3y into the x in the bottom equation. So 2 times 3 minus 3y plus 6y is equal to 6. I'm going to solve this equation. 6 minus 6y plus 6y is equal to 6. And I end up with 6 equals 6. So I no longer have a variable. This is the case where I have a consistent but dependent solution. So there are infinitely many solutions to this system. It doesn't matter what x is or what y is, I'm always going to have an ordered pair that's going to be a solution. So my answer here is infinitely many solutions. In the next example, I don't see either one equation being easier to solve for a variable than the other. So I'm just going to look at the top equation, and I'm going to solve it for y. So I get y is equal to 5 halves minus x. And I'm going to substitute 5 halves minus x. You might want to write that as a decimal if you wish. I'm going to leave it as a fraction into the other equation. So I have negative 2 times 5 halves minus x minus 2x is equal to 3. I get negative 5 plus 2x minus 2x is equal to 3. So negative 5 is equal to 3. We know this is not true. This is a false statement. So that means this system is inconsistent. There is no solution.